Alright, so this is the walkthrough for your Quiz 3 study guide. Quiz 3 is going to be on solving these equations by using strategies 1 through 3. So these 7 problems on the study guide use those 3 strategies. You just have to determine which one to use. Alright, so we can start with number 1. Number 1, if you look at it, you know that you can condense these logs because they have similar bases. You can kind of say they have base 10. And you can condense because of this plus sign. So knowing that, we can say that this problem requires you to use strategy 2. To condense these logs, because it is addition, you'll be multiplying what's in your parentheses. So it would be 2 times x minus 5. And then keep the other side, the equal side, the same. Awesome. And then we can distribute this 2 to simplify it. We get 2x minus 10 equals log 7x minus 12. Alright, with strategy 2, because they are logs that have the same bases, we know that we can just set what's in our parentheses equal to each other. So that means that we're going to have 2x minus 10 equals 7x minus 12. Alright, and then we're just going to isolate our x. So let's subtract 2x from both sides. We get negative 10 equals 5x minus 12. Isolate even more by adding 12 to both sides. Those cancel. 12 minus 10 is 2 equals 5x. And our last step would be to divide by 5. So x equals 2 divided by 5. Now before we can say that that is our final answer, we need to check it. By checking it, you need to plug 2 over 5 into the x's that are in our original equation. So, log of 2, there's no x's to plug in. This is a positive, so that's good. We got log 2/5 minus 5. So we know that 2/5 is less than 1, and if it's less than 1 and you're subtracting 5, this is going to become a negative number. So this is not okay because we cannot take the log of a negative number. So actually, x cannot equal 2 over 5, which means that this log has no solution, and that would be our final answer. Alright, so for number 2, we can see the strategy that would best help us is number 1. The first step for this is to condense these two logs because they do have the same base, so you're able to multiply these. So you can do log base of 2, 4 times a plus 1 equals 3. Simplify that to 4a plus 4. Now strategy 1 tells us that we can just change this into an exponential form. So to do that, we could start with base 2 exponent 3 equals 4a plus 4. So 2 to the third is 2 times 2 times 2. That is 8 equals 4a plus 4. Let's subtract 4 from both sides. We get 4 equals 4a. Divide by 4 from both sides to isolate a. And we have a equals 1. But we're also still not done because we need to check. So let's plug in 1 for both of these logs. The first one, there is nothing really to plug in, so that checks off. And the second one, plug a in as 1. Because this is a positive number, this also checks off. So our final answer is a equals 1. Number 3 calls for strategy 3. So strategy 3 means you need to have similar bases. These are not the same bases, but they do, or they can be changed into similar bases. So you can represent 9 as 9 to the first, or 3 squared, because you know 3 times 3 is 9. For 27, you can do 27 to the first, or you can do 3 to the third, because 3 times 3 is 9, times 3 again is 27. So now we have these similar bases with these new exponents that we need to multiply to our old ones. So this then turns into base of 3, 2 times v minus 2 equals base of 3, 3 times v squared minus 3. Now that we have similar bases, we can distribute the 2 and the 3 and then set the exponents equal to each other. So let's just distribute first. So we got base of 3, 2v minus 4 equals base of 3, 3v squared minus 9. Now let's set the exponents equal to each other. 2v minus 4 equals 3v squared minus 9. Let's shift everything over to one side so that we can get it equal to 0 and form a quadratic. Negative 9 plus 4 is negative 5. Alright, now we are going to factor. The way I learned to factor was kind of like a guess and check. So I know it needs to be 3v and v, because 3 times 1 equals v, that's the only way possible. To multiply to 5, again, the only way possible is 5 and 1. I just need to guess and check where the 1 and the 5 go. If I put the 5 and the 1 here, I would get this product to be 1v and this product to be 15v. There is no way that 1v and 15v can add to 2v, so that's how I know that that is not where they are supposed to be. So let's just switch them. Alright, so now we got 5v and 3v. To add to a negative 2, it needs to be a negative 5, because negative 5 plus 3 is negative 2. So we're going to slap the negative onto the 5 and the positive over there. Alright, now that we have our factors, we can set them equal to 0. So 3v minus 5 equals 0. To isolate for v, we could just add 5 over and divide by 3. So v equals 5/3. The other factor, v plus 1 equals 0. Subtract the 1, v equals negative 1. And then if we did want to check this, I'm going to check the negative 1. 9, negative 1 minus 2 is 9 to the negative thirds, which is the same as 1 over 9/3, sorry. And 27, negative 1 squared minus 3. Negative 1 squared is 1, and 1 minus 3 is negative 2, which would just be 1 over 27 squared. And these two are equal, so we got both answers are correct. Alright, if we take a look at number 4, right away, without even condensing, we can see that because they have similar bases, we can set these two equal to each other. So we got 5r squared minus r equals 11r minus 4. Let's get everything to one side so that we can form our quadratic. Equals 0 always. Alright, now we're going to factor again. Kind of what I said like last problem, it's just a guess and check for me. I know 5 and 1 have to equal 5. Now here, you can either do a 4 and a 1 or a 2 and a 2. Let's just try 2 and 2 first. That would be 2r. That would be 10r. Oh, so that works. It needs to be a negative 12, so these both need to be negative. Perfect. Now we take our two factors, set them equal to 0. R minus 2 equals 0, so R equals 2. And need to check. So we got 5 2/5 squared minus 2/5. That will be a positive. And we got 11 2/5 minus 4 will also be a positive. So we got R equals 2/5 is one of our answers. And now we plug in R equals 2. So 5 2 squared minus 2. That's 20 minus 2, that's 18, positive. And 11 2 minus 4, 22 minus 4. It's also 18. Now you guys can also see how that works. They are equal to each other. So R equals 2 is also one of our answers. Moving on to problem 5. This is going to use strategy 3. Strategy 3 means you need to have similar bases. These are not similar bases, but they could potentially be. To get the base of 2, all you can do is 2 to the first power. To get the base of 16, you can do 16 to the first power, so it sounds like R. But you can also do 4 squared, or you could even do 2 to the 4th. That is 2 times 2 equals 8, times 2 equals, 2 times 2 equals 4, times 2 equals 8, times the last 2 would equal 16. So, this is going to be our new base and exponent. We are going to have 2 to the 4y, multiplying these two, equals 2 to the 3y minus 6. Don't need to change that one because it already has base of 2. Alright, awesome. Now we got same bases. So that means we just set the exponents equal to each other. 4y equals 3y minus 6. Subtract 3y from both sides. You get y equals negative 6. And that works. So that will be our answer. For number 6, we are going to jump back and use strategy 1. So to do this, I want to get the logs on the same side of the equal sign and my constant, which is 1, on the other side. So I can add log 9(3) to both sides and get log base 9 of b plus 3 plus log base 9 of 3. And then if I wanted to add my 1 over, it would just equal 1. Alright, then using our log property, we know that this addition sign with the same base means that I can multiply these. So I can just turn this into log base 9 of 3 times b plus 3 equals 1. Let's simplify that to 3b plus 9 equals 1. Alright, now with this equation, we can turn this into exponential form. So we know that our base is 9, our exponent's 1, and it would equal our remaining value 3b plus 9. 9 to the first is just 9. Then, let's subtract 9 from both sides so that we can isolate our b. This would actually cause both 9s on both sides to cancel out, so we would get 0 equals 3b. To finally isolate b, we can divide by 3. When the 0 is in the numerator, it always will equal 0, so we have b equals 0. And then we are going to check like always. We got log base 9 of 0 plus 3. That works because this is a positive number. And on the other side, we got negative log base 9 of 3 is already a positive number. So that also works, which means that our answer is b equals 0. Alright, last problem that I'll throw at you is another strategy 1 problem. So, like we did before, we're going to move all the logs to one side and all of our constants to the other side. So, one thing we really need to move is the 7. So we can subtract 7 from both sides. Both of them end up canceling. So we have log base 2 of negative 4z minus 11 equals 0. And then once again, we're going to change this into our exponential form with our base of 2, exponent of 0, equals remaining value, negative 4z minus 11. Anything to the 0 power equals 1. So now we have 1 equals negative 4z minus 11. Now we're going to isolate our z. We're going to add 11 to both sides. So now we have 12, cancel that out, equals negative 4z. And then to finalize finding what z is, we can divide by negative 4 from both sides. And we can get z equals negative 3. And cannot forget after this video that you need to check. So we're going to plug in negative 3 into our log. Log base 2 of negative 4 times negative 3 minus 11. This would be log base 2. Negative 4 times negative 3 is 12. So we have 12 minus 11, which is just log base 2 of 1. And because that is a positive, it works, and our answer is z equals negative 3.